Hey guys, so we are on our first lesson, or actually this isn't the first lesson, this is like the third lesson? Sorry. But it's the first lesson where you get to learn a shortcut, and I bet you will be super happy about that. So we're on day 3.3, day 1, the power rule. Okay. Because I got the power. All right, so rule 1, the derivative of a constant function. This is going to be something that you are going to use the entire year, so you got to know it. So it says, let C be a constant, then d dx, the derivative of C, the derivative, oops, maybe zoom or focus on there. The derivative of a constant will always equal 0. Always, always, always. So let's find out why. So let's take a look at the first example. It says to graph y equals 4. What is its derivative at every point? Okay, well, let's just draw a quick sketch. And let's say that this is a y value of 4. Y equals 4 is a horizontal line through that y value. So what is the slope of a horizontal line? You should be thinking, oh, the slope is 0. Right. So y equals 4. 4 is just a number. A number is called in math a constant. And since the slope is the same as the derivative, then since the slope of that line is 0, then the derivative of that constant number is 0. So no matter what the constant is, it could be 1,000, the derivative of 1,000 is still 0 because the slope of that line is 0. And derivative is slope, okay? So we'll skip example 2. We don't need that one. So that's the first part of the rule. Second part is the actual power rule itself. Rule 2, the power rule. If n is any real number, then d dx, the derivative, of x to the nth power is n, notice how that drops in front, of x to the n minus 1 power. So whatever that exponent is, it drops in front, and then it goes down a degree on the exponent. Okay, it's a super easy rule, and it's going to be way, 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 way quicker than doing the x plus h minus f of x all over h type thing. Okay, so example 3 says find the derivative of y equals x to the third by using the definition of derivative. So since we're going to be using the definition of derivative, we're going to do it the old school way, the way that we've been doing it this whole time. And then we're going to, if you look at part B, by looking ahead, we're going to use the power rule. And we're going to compare, and you're going to see how much quicker it's going to be to use the power rule, and you're going to love it. All right, so the limit as h approaches 0 of, I got to plug in x plus h. So x plus h quantity cubed minus the original, which is just an x cubed, all over h. Sorry, the birds are really loud today. They're just talking up a storm. Oh, Mando's being creepy right now. Mando, he talks in this deep, like, old man voice, and it's just creepy. Freaked out my mom. You know, if my mom's getting freaked out by a bird, it's bad. Anyways, so we have the limit as h approaches 0. We got to multiply that out. When you multiply x plus h times x plus h times x plus h, the quickest way to do it without having to actually multiply it out using product rule the whole way through is to use a Pascal's triangle. So we know that on the third row, because it's the third power, the coefficients would go 1, 3, 3, 0. So the first coefficient is a 1, x cubed. And then the 3, the x's go down a degree, but then the h's go up a degree. And then a 3, x's go down a degree, h's go up a degree. And then the 1, the x's go down a degree, h's go up a degree. And then minus x cubed all over h. Now, if you don't want to use Pascal's triangle, you can totally multiply that out. It's not a problem. You're still going to get this. Okay. All right. Let's get a little cancel happy. X cubed and negative x cubed, they gone. And then all I have is this, but each term has an h in it that I could factor out. I could cancel it out. So cancel, 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 cancel. Okay. So now, if I bring this down here, I have the limit as h approaches 0 of 3x squared plus 3xh plus h squared. Okay, let's go ahead and plug in the 0 for the h. And 0 times anything wipes this out. This will get wiped out, this will get wiped out. So all I have left is a 3x squared, and that is the derivative. Okay, using the long way that we've been using since the end of Enhanced Math 3 last year. Okay, now let's try it out with the power rule and see, okay, what's the big deal, Mrs. Garcia? What's the big deal? Because that took forever. And it wasn't hard, it's just it takes forever. Okay, so using the power rule, we're going to take the derivative, so d dx, of the x cubed. Okay, I technically don't need the parentheses around that because it's just one term, but it doesn't hurt anything. Anyways, so if we follow the power rule, that means we have to drop the exponent down in front. So the exponent is a 3, so I'm going to drop it down in front, times x to the n minus 1 power. So that degree has to go down 1, so 3 minus 1. Well, 3 minus 1 is a 2, so now this is a 3x squared. Oh my gosh, I'm done. Look at that. Literally, it's just one step pretty much, because we could totally do all of this on our head and get straight to that answer versus all of that. So the point of doing all of this is to get the basics down, understand why we're doing what we're doing, and then we get to use some shortcuts. Gotta love it. Calculus can be so quick. It can be lengthy, but it can also be so quick. And I love it. So doesn't that blow your mind? Isn't that so cool? We're going to be using this a lot. You're going to get a lot of practice on it. Okay. Rule number 3. Sum and difference rule. So when we take the derivative of f of x plus g of x, it's the same as taking the derivative of f of x and adding it to the derivative of g of x. Same thing as when we're subtracting. Okay. So we could take the derivatives in pieces and then piece them together. All right. So let's take a look at example 4. It says find the derivative using the power rule. Okay. So if I use the power rule, the 2 is going to drop in front of the x, so that'll be a 2x, but it goes down a degree, so instead of x squared, it's now an x to the first power. And then I got to drop the negative 5 in front of the x, so minus 5x to the negative 5, and then I have to drop it down a power, so negative 5 minus 1 is a negative 6. Okay. We don't ever leave a negative exponent in our answer, and you guys learned that way back when in Math 2. If you had Math 2 with me, you were told to drop it like it's hot. In other words, invert it so that the exponent is now positive, but only drop the term that has the negative exponent. Don't you dare drop anything else. The negative 5, does not have a negative exponent. Its exponent is technically a 1. So there was nothing wrong with its exponent. You leave it there. Okay? So final answer then would be a 2x minus 5 doesn't drop, but the x to the 6th is now in the denominator, so that it has a positive exponent. That is a 6. I'm sorry it looks crappy, but my pen got away from me. And that's the answer. See, now we don't have to do the whole x plus h minus f of x type thing, and it's just way quicker now. And if you were looking for solutions or answers online, a lot of the times they were using power rule. And that's why it didn't make sense, because it didn't look like what we were doing. And now it will. Okay, so we're not going to do all of these. I'm going to do every other one. So I'm going to highlight the ones that I'm doing. Doing B. We'll start there. And let me zoom in a little bit. Okay, so we're going to find the derivative of s equals t to the 3/4 minus t to the negative 3rd. Okay. Well, first of all, that 3/4 needs to drop in the front. So that would be 3/4 t to the 3/4. Remember, it has to drop 1. So I have to subtract 1, but let's go ahead and get a common denominator. So subtracting 1 with a denominator of 4 is the same as subtracting 4 over 4, because 4 over 4 is 1. All right, and then here we also have to drop that -3 in front of the t, but there's a negative in front of the t, and when I drop down to -3, negative times negative is positive, so plus 3t to the -3 minus 1. Remember, you drop the exponent in front, and then you bring it down a degree, so we have to subtract 1 from the degree that was already there. Okay, let's clean this up. So we have 3/4 t. 3/4 minus 4/4, well, that's -1/4. Plus 3t, -3 minus 1 is a -4, so 3t to the -4th. Remember, we never, ever, ever leave negative exponents in our answer. Never, ever, ever. So the term that has a negative exponent, we got to drop it like it's hot. This one also. Okay, so we're going to have 3 over, there's already a 4 in the denominator there because we had the fraction 3/4, so now there is a t to the 1/4 power with it, plus 3 had nothing wrong with it, so it stays up top, but now we have a t to the 4th in the denominator. And now there's only one more thing that we have to fix, and that is that t to the 1/4 power. And so you have to recall, okay, well, what does it mean to have a fractional exponent? Well, if you remember from Math 2, I just taught this to my Math 2s, that denominator of the fraction means that's the type of root it is. So since the denominator of the fraction is a 4, this is a 4th root of t to the 1st. So we have a 4 out front, and then the 4th root of t to the 1st, so just t, plus 3 over t to the 4th. And there's our answer. Okay. All right, next one, we're gonna skip C and do D. So we have y equals x cubed over 3 minus x. Okay, so let's do this. We've got to drop the exponent in front, so we'll have a 3x squared over 3. Okay, minus the x is to the first power, so if we bring down a 1, it's just a 1, and then an x to the 1 minus 1 is 0, so an x to the 0 power. But what is anything to the 0 power, guys? Do you know? It's a 1. So that's -1 times 1 is just -1. And these 3's cancel, so we just have x squared minus 1. Isn't that so easy? It's so easy. Okay, next one, we're skipping E, we're gonna do F. I got new highlighters because they were on sale at Target. I had a cartwheel coupon off, and so I'm like using all my colors because I like colorful things. Anyways, all right, so let's take the derivative. So I want to point out that the exponent there is a 1, so when we bring the 1 in front, 2 times 1 is just a 2. And then that x now is to the 1 minus 1, which is 0. And then what's the derivative of 1? What's the derivative of a constant? Do you guys remember? It was from the first page, that first rule. The derivative of constant will equal 0. Okay, so plus anything to the 0 power is 1, so 2 times 1 is 2, 2 plus 0 is 2. So the derivative of that whole thing is a 2. So pretty much when you're taking a derivative using the power rule, you can ignore any time you see a constant. It means nothing to the derivative. All you have to do is look at the exponent, drop it in front. If there's a number in front, multiply it, and then bring the exponent down a degree on the variable. That's it. It's so easy. I hope you guys are liking this. Simplifies a lot of your life for right now. Simplifies it, yet makes it a little more difficult just because now you know how to do these problems. You got to practice them. Got to understand them. So you're like, yeah, right, Mrs. Garcia. All right, so let's try this one. F of x equals 9 times the cubed root of x squared. So in order to do this, we have to rewrite the problem. We have to remember what it means to have a third root of something. So that means, just like we did up here, you know how we converted the 1/4 power to the 4th root of t? We're going to do that same thing. We're going to convert this radical into a fractional exponent. So this is going to give us 9x to the 2 because it's x squared, but because it's a cubed root, it's to the 2/3 power. Okay? And don't forget, when we take the derivative, we bring that power down in front. There's a 9 down in front. So that means we're going to have a 2/3 times 9x to the, now we have to take the power that we had up there, which was a 2/3, and take it down by 1 power. So if we take it down by 1, let's get a common denominator. So I need a common denominator of 3, and if I'm subtracting 1, that would be 3/3. Okay? So then, what does that become? Well, 2 times 9 is 18. 18 divided by 3 is 6. Ooh, that worked out nicely. X to the 2/3 minus 3/3 is -1/3. Oh, negative exponent. What do? We got to drop it like it's hot. So only the term that has the negative exponent, though. We got to drop it. So we'll have 6 over, and let's also remember that x to the 1/3 power, let me just write it. Let's change it back to a root. So that'd be 6 over the cubed root of x to the 1st, or just x. Boom shakalaka, there we go. Isn't that fun? These are fun. I like these. I hope you do too. I really do. If you're in calculus, you've got to be enjoying it at some point, right? Gotta be. Or try to find the joy. Try to find the joy in things, guys. It's okay. It's okay to be joyful. All right, letter J. Y equals 2x to the 4th plus 5x cubed all over 6x. All right, so this one's a little bit different. It's a fraction with 2 terms in the numerator, 1 term in the denominator. What do we do? Well, the first thing is we're going to need to break apart that fraction. So make sure you add this to your notes. Whenever you see a problem like this, you got to know, I got to break that apart. Okay? So when I mean break it apart, I mean let's split this into 2 fractions instead of just having the 1. So that means I would have 2x to the 4th over 6x plus 5x cubed over 6x. So do you see, guys, how I split that apart? It still means the same thing if they have common denominators. So if I were to combine them again, I would get back to the original. So it still means the same thing. But now I get to get a little cancel happy. So let's see, 2 goes into 6 3 times. X cancels with one of them up here. Now there's an x cubed. And this x cancels with one of them up here. So that's an x squared now. Okay, so now I have a x to the 3rd all over 3 plus 5x squared all over 6. Notice I have not even taken a derivative yet. But now that I have this simplified, I have it set up so that I can take a derivative. So now we can do the d dx. We could take the derivative of x cubed over 3 plus 5x squared over 6. Now we can take its derivative. Okay? Well, we got to take that exponent, drop it down in front, so that will be a 3x. Now drop down the exponent by 1, so x squared all over 3 plus, bring the 2 down front. There's a 5 there, so 2 times 5 is 10. X to the first now, because we're going to take it down a notch, take it down a degree, all over 6. And we can reduce that. See, the 3's cancel. And let's see, 2 goes into 10 5 times, 2 goes into 6 3 times. So now we have x squared plus 5x over 3. Imagine doing this problem, doing the x plus h minus x all over h thing. It would be pretty lengthy. We could do it, it would take a lot of space on paper. Nobody's got time for that, now that we know the shortcut. All right, next page. Rule number 3, the constant multiple rule. What color have I not used yet? Purple, make it purple. The constant multiple rule. Let me zoom out a little bit. It says if f is a differentiable function of x and c is a constant, then d dx of c times f of x, so that means that this is a factor of the function that's brought out front. It's just that constant times the derivative. Okay. So that means we're going to be factoring a little bit. Remember those words that you were told back in the day when you learned how to factor, back in math too, how you were always going to need to be able to do that and it was going to follow you all the way up until the end of your math career? Well, it was true. We were telling the truth. So, in other words, we can pull the constant out front, aka factor it out, and take the derivative of what remains. Because it will be way easier to factor out a constant first and then take the derivative versus taking the derivative and having to deal with big numbers. So let's take a look at example 4. We're going to find the derivative of 27x to the 4th minus 54x to the 6th. Okay. And let's do this. So since it says that we can factor, let's actually try and see if there is a common factor between 27x to the 4th and 54x to the 6th. But we don't want to just factor, we want just a constant. So we only want to look at the numbers. So between 27 and 54. Well, 54, does 27 fit in 54? Yeah, it does, twice. Oh, perfect. So that means I could factor out a 27. So let's write that down for our notes. We're going to factor a constant out. So we're going to factor a 27 out. And when we factor that out, we're going to have x to the 4th minus 2x to the 6th. Okay. Well, now we can take the derivative. And we can just leave that constant out front of the derivative. And let's just do it. Do the derivative on this part. So the 4 gets dropped down, so that would be a 4x, and then go down a degree, so x to the 3rd, minus the 6 drops down, 6 times 2 is 12, and then that degree also drops down. So 27 times 4x cubed minus 12x to the 5th. And then we didn't have to deal with massively large numbers. It makes it a little bit easier when we do it this way. Okay. Let be. Let's try it. Let's see what's in common. Well, first of all, we're going to need to switch that square root of x to x to the 1/2 power because it's a square root and x is just to the first power. And they do have a common constant factor of a 4. So let's go ahead and factor out a 4. So we'll have 4 times the quantity. Switch that x to the 1/2 power because it's the square root of x. Minus 4 times x to the 5th because we factored out that 4. Okay. And now we can take the derivative. So keep the constant out front. And the derivative of this, we bring the exponent down in front. That would be 1/2 x. And then if I subtract 1, 1/2 minus 2 over 2 is negative 1/2. Okay. And then minus, bring down the 5, that would be 20 x to the 4th. Okay. So let's switch this. That's a negative exponent. We gotta drop it like it's hot. I'll stick with my orange color. So we have 4 times. Let's see, we have a 1 in the numerator, so just stay up there. 1 and then 2 times x to the 1/2 power. But remember what x to the 1/2 power means. That's just the square root of x. And then minus 20 x to the 4th. All right. And there we go. All right, so let's look at example 5. It says find an equation of the normal line to the curve y equals x to the 3rd minus 3x plus 1 at the point 2, 3. So remember at the end of last chapter, we were doing this and we had to use the x plus h minus x all over h type thing. But now we know how to take a derivative using the power rule, and it's way quicker. So let's go ahead and find that tangent line, which remember is the derivative. So let's take the derivative d dx of x cubed minus 3x plus 1. Okay, well, the derivative will be, well, we bring down the 3 in front, so 3 and then x squared minus, if we brought down the 1, it would just be negative 3 times 1, so minus 3, and then that's an x to the 0, which is just a 1 anyway, and then that's a constant, so it doesn't mean anything. Okay, so this would be the slope, but that's the slope formula. Now we need to find the slope at that point where x is 2. They gave us that point, so let's plug in a 2. So 3 times 2 squared minus 3. 2 squared is 4. 4 times 3 is 12 minus 3. So the slope is a 9. So when we're finding the normal line though. So we need the tangent line because this tells us the slope of the tangent line. And we know that the normal line is the opposite reciprocal of that. So let's now find the normal line. Okay, so the opposite reciprocal of a 9 is a negative 1/9. So that means we'll have n of x for normal line equals negative 1/9 x times, sorry about that, my sister called and paused it real quick. All right, so negative 1/9 times x, and then the minus 2 from that point it gave us, and then the y value is a plus 3. Let's go ahead and distribute. So that would be negative 1/9 x, negative times negative is positive, 2/9, plus, let's go ahead and get a common denominator, multiplying top and bottom by, by 9. 9 times 3 is 27. So n of x would equal negative 1/9 x. 27 plus 2 is 29, so plus 29 over 9. Because we know that in the real world, we don't always get super nice numbers. It's just not realistic. All right, example 6. It says find the points on the curve y equals 2x cubed minus 3x squared minus 12x plus 20, where the tangent is parallel to the x-axis. Okay, so we're finding points on this curve where the tangent is parallel to the x-axis. If we're parallel to the x-axis, x is horizontal. So being parallel to a horizontal axis means that we have a horizontal line, and we're going to be looking for where the slope is 0. Okay. All right, so the first step is, well, let's find the derivative so we could have the slope formula. So that means we need to find y prime. Let's find the derivative of that. So if we drop down the 3, there's a 2 in front, so that would be 6x squared. Drop down the 2, there's a negative 3 in front, so minus 6x. And then drop down the 1, there's a negative 12 in front, so negative 12. The constant doesn't matter because the derivative of a constant is 0. Okay. So now that we have the slope formula, when we're finding where the slope is 0, that means we have to set this equation equal to 0. So we're going to have 6x squared minus 6x minus 12 equals 0. I see that there's a common factor of a 6, so let's factor that out. So I'll have x squared minus x minus 2. And anytime we have a quadratic set equal to 0, you always got to factor it to solve. And we're going to get 2 solutions. So let's see, it's going to be an x minus 2 and an x plus 1, because negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. And we'll get that x equals 2 and x equals negative 1. Okay? All right. So we have our 2 solutions for x, but now we need to find the points on the curve. So we have the x values, we need to find the y values. So what we can do is we can either use synthetic division to find the y values, or you could just plug in the x values right here and find the y values. I'm going to show you how to use synthetic division. We've done it before in Math 3 first semester. It's just been a little while. So let's start with the 2. So x equals 2 goes in the box, and then write down all the coefficients of the original equation. 3, 2, 1, 0. Make sure all your terms are there, because if you have a missing term, so say we were missing the x squared term, you'd have to put a 0 in its spot. Let's bring down the 2. 2 times 2 is 4. 1, 2. Negative 12 plus 2 is negative 10. Negative 10 times 2 is negative 20. 0. So the y value is 0. So when the x value is 2, the y value is 0. And there's one of the points. Let's try the other one. Negative 1, use the same coefficients. Now, like I said, you could totally just plug it in for x and solve, but this I feel like is way quicker and less chances of making a mistake because that polynomial is just so big. All right, bring down the 2 and then multiply. Negative 2, negative 5, positive 5, negative 7, positive 7, 27. So when x is negative 1, the y value is 27. And these are the 2 points where the tangent is parallel to the x-axis, so where the slope is 0. Okay? All righty. And we'll skip example 7 just to save us some time. And that's it for 3.3 day 1. You'll have a homework assignment that goes with this, and then we'll be on to 3.3 day 2.
Do you make